Hi, in Notes 56, we're going to be adding versus multiplying polynomials. Polynomials mean many terms. So it could be anywhere from 1 to, 4 or 5 terms. So what you need to be aware of as we look at a visual of this is a constant is just worth like one number. A variable you're going to see as in x, so it's a vertical tile. And then a variable raised to the second power, because this would be x, this is an x this way, times an x that way. So basically x times x is equal to x squared. So if you take a look at problem 1, you can only add terms if they are alike, and the power does not change. So on this case, you have 1, 2, 3 x's plus 3 constants. On number 2, you have an x squared plus 3x. So on number 3, you have 2x squareds, and then you have 4x's, so that's plus 4x, and then you have plus 1. All right, let's take a look at without the tiles. Combining like terms, put the higher power first. So in this situation, you don't have different powers. On number 4, they're all x squareds. So the only time you add the exponents is if those plus signs were multiplication, but they're not. So this is 1x squared plus 1x squared plus 1x squared. It's kind of like 1 apple plus 1 apple plus 1 apple gives you 3 apples. So that would be 3x squareds. All right, number 5. This is where you put the higher power first. So we have 4x squared plus 1x squared. That makes 5x squareds. And then you have 7x plus 8x, which is plus 15x. All right, number 6. Here, this is subtracting. So again, you still start with your highest exponent. Well, number 6, you don't have anything else but squareds. So you have 5 minus 8 is negative 3x squareds minus 4x squared. Same signs, add and keep. Same signs, add and keep. Different signs, subtract. Okay, let's look at number 7. Your highest exponent is x squared. So we have 1x squared plus 5x squareds gives us 6x squareds. Then we have a negative 3x right here. So that's just minus 3x. That is the only x term that you have. Then we have negative 7 plus 1 for our constants. Same sign, add and keep. Different signs, subtract. So 1 from 7 makes 6. Take the sign of the higher. The higher number is 7 and it's a negative. Then you'll be exact. So it'll be 6x squared minus 3x minus 6. All right, let's take a look at number 8. We're going to distribute. This really doesn't look any different than what you have done since the beginning of the year. So you're going to bring down the 8. Your negative 3 is your distributor. So negative 3 times x is negative 3x. Negative 3 times negative 7 is positive 21. So your final answer will be negative 3x. And then this is 8 plus 21, which is 29. All right, let's take a look at problem 9. Let's see, we would have 5x squared plus 4 minus 5x squared. That minus sign in front of a parenthesis just means to take the opposite of everything inside, or you can treat this like a negative 1. So negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. So now we start with our highest exponent. So we have 5x squared minus 5x squared. So those would actually just cancel out. So then we have a negative x, and then we have 4 minus 3, which is plus 1. All right, let's go ahead and take a look at writing the expression for the perimeter in simplest form. So remember that the perimeter is the sum of all the sides. So there's a couple ways. I know at the beginning when we did this where we didn't have any exponents other than 1. That was back in like semester 1. I had you line these up. So 6x squared minus 12x, and then 2x squared plus x, and then 9x squared plus 10x. It's just another way just to keep everything lined up if you want to. So 6 and 2 is 8, and 8 and 9 is 17x squareds. And then you have, I think I would combine the positives, so 10 and 1x. So right here, 10x and 1x is 11x, and then minus 12 is a negative x. Another thing you could do is just go around the horn and just go 9x squared plus 6x squared plus 2x, and that gives you your 17x squareds, and then negative 12, and then you've got 10 and 1, make 11, and then minus 12 gives you a minus x. All right, number 11. If you're going to line these up, I would definitely start with the larger polynomial, which in this case is called a trinomial because it has 3 terms. So you have x squared plus 2x plus 1. So I've dealt with that one. And then you have this one is x squared. So I put it under here. And then x squared plus 2x squared. Now, on this one, there is not a middle x term. So your plus 2 would be over here if you're keeping everything lined up. And then the next one is just x squared. So if you're lining up, you have to be real careful. So we have 1, 2, 3, 4x squareds. We don't have any other x's. So this would be plus 2x. And then 1 plus 2 gives you 3. And then another way, again, you could work this out is you could just go around the horn and combine your like terms. So we have 1x squared, 2x squared, 3x squared, 4x squared. And then we don't have any other x's, so that's 2x, so it'll be plus 2x. And then you've got 1 plus 2 makes 3. So I've just showed you a couple different ways that you can do that. All right, now there's different rules here for different operations. So when you add and subtract polynomials, they're like terms, you keep the same exponent and same power, or the same power. It means the same thing, okay? So you're just going to combine the coefficients. That will change, but your exponents will not. So adding and subtracting, your exponent will stay the same. Your coefficient is the only thing that will change. And also write these in descending order. So let's go ahead and just work 12a, 13a, and 14a. So 2x squared plus 1x squared gives us 3x squared. And then you have 5x plus 8x is 13x. 13a, you have 1x squared, and 1x squared gives you 2x squared. And then you have 7x plus 1x is 8x, and then plus 6. For 14a, you have 5x squared plus 1x squared is 6x squared. And then 1x plus 7x is 8x. All right, let's take a look at multiplying polynomials. They do not have to be like terms here. I didn't mean to write on that. You multiply the coefficients and add the powers. And the coefficients might change. The exponents will change. So let's take a look and see if you remember. So we can pull out all of the coefficients. So 2 times 5 is 10, times 8 is 80. So this would be 80. X, now then, let's take a look at our exponents. In fact, let me do this in a different color. You have a 2 right here. Now, don't forget, this is understood to be a 1. So basically, we have 2 plus 1, another 1, and then plus the 2 right here. So we have 2 plus 1 is 3, plus 1 is 4, plus 2 is 6. So this would be 80x to the 6th power. All right, let's take a look at 3b. So we have 6 times 7 is 42. X to the 2 plus 2 is 4. Plus 1 is 5. Plus another one is 6. So that's another one. This like 12b is raised to the 6th power. Number 14b. We've got a 5 times 7 is 35. Times 6 gives us 210. X, and we've got 2, 4, 5, 6, 7, 8. So 210 x to the 8th power, not powder, power. All right, let's see what we have here. So on 15 through 18, it says multiply first and combine the like terms. Oh, okay, we can do that. So 3x times 2x. So 3 times 2 is 6. X to the 1 and 1 make 2. Plus 4x and 1 make 2. So these are like terms. So now we can add. So 6 plus 4 is 10. You keep the exponent the same. It's like 6 apples plus 4 apples is 10 apples. All right, let's take a look here. Ooh, we have a fraction. Oh no. Come on now. Let's buckle up. We can do this fraction. So 9x squared. Negative 2/5 times x is minus 2/5 x. Without a calculator, I've taught you how to do this. So you can go negative 2 times negative 15. That's right, it's 30. 30 divided by 5 is 6. Now see, that wasn't that bad. And then plus, I'm not for sure why I put 2x squared in parentheses. It really doesn't need to be in parentheses, but plus 2x squared. So now I look at my like terms starting with the highest exponent. So I've got 9x squared, plus 2x squared is 11x squared. I don't have any other x's, so it's just going to be minus 2/5 x. Whew, I bet you're glad because, if you would have had to combine the negative 2/5 with something else, I don't know if you could do it. And then plus 6. All right, let's look at 17. What is the coefficient of x from problem 16? So we're going to look at problem 16 and the coefficient of x. Well, here's our x term right there. So the coefficient is negative 2/5. Well, that wasn't that hard. All right, let's look at number 18. The width of a rectangle is 5. Oh, I am such a visual person. I am going to draw out this rectangle. So the width is 5x minus 4. The perimeter of the rectangle is 14x plus 4. What is the length? Oh, you know what? I kind of redid this. I messed up. This is kind of what we call the length. Sorry about that. So here's the width, 5x minus 4. 5x minus 4. Okay, so we want to know what the length is going to be if the total distance around the outside is 14x plus 4. So first of all, I think what I'm going to do is combine the widths. So I have 5x and 5x make 10x, and negative 4 is negative 8. So how do you get from 10x to 14x? That sounds like a cat. Sorry about that. 10x to 14x, that would be 4x. And then from negative 8 to 4, let's see, that would be plus 12. So that's what the total length would be. Now then, there are two of them. So basically, you have to divide that in two. Okay? So the length, half of 4x would be 2x, and half of 12 would be 6. So let's just see if we did that right. So we've got 5x and 5x is 10x, 2x and 2x is 4x. So 10x and 4x is 14x, which is what we want. And then 6 and 6 is 12 minus 8. 12 minus 8 gives us 4. So we did that correctly. All right, that's all we do. See ya.